All right, boys and girls, welcome back to Fourth Bell, a little 5-minute lesson on coordinate proofs. So this is, I guess, such a big topic that they're taking 2 of the 4 sections from Unit 9 to focus on coordinate proofs. Next is circles, then comes parabolas, okay? So basically, this is a transition back into algebra from geometry, okay? So first, I put this one up just so you can see there's more than one ways to do this, okay? So notice, Dakota and Jung were both tasked with showing that this triangle was a right triangle. So before you do anything, you need to think about the properties of a right triangle, okay? There's 2 that come to mind. A right triangle has at least one, sorry, not at least, exactly one what? Right angle, so we can go about it that way. Or if a triangle is a right triangle, then a squared plus b squared equals c squared. So there's 2 different ways we could show this. Notice Dakota finds the slope of AB. She finds, or he, I don't know if it's Dakota, she finds the slope of BC. And then notice the slopes are opposite reciprocals. So that proves that line AB has what relationship with line BC? They're perpendicular, and so we've just proven it's a 90-degree angle. It's a right triangle. John, on the other hand, decides to use Pythag. So in order to use Pythag, we need distance formula. Notice AB is radical 13, BC is radical 13, and AC then is radical 26. If you put those into the Pythagorean theorem, it works. Therefore, it is a right triangle. Does anybody notice anything about this particular right triangle? What kind of right triangle is it based on this? Okay,
45, 45.
Very good. It's 45, 45, 90, because if you do radical 13 times radical 2, you get radical 26. So that would be like an even better answer to that question. All right. I can't make this video too long, so this is the last slide. We're going to do this. This is a coordinate proof. What do you notice about the coordinates? There's no numbers except for 0. Why do we use 0, 0? Because it makes it easier. Okay? You don't have to use 0, 0, but it makes it so much easier. So what are we trying to do here? We're trying to restate the trapezoid midsegment theorem, and then we're trying to prove it. Does anybody remember the trapezoid midsegment theorem? Okay, I thought you might say that, so I'm prepared to let's Google it. Help me understand the trapezoid midpoint theorem. Modern learning. This is how you do it, okay? Well, the trapezoid midpoint theorem states that the segment connecting the midpoints is both parallel to the bases, and what happens when you add 2 things and divide by 2? What's that called? It's the average of the 2 bases. So that's what we have to show. We need to show that EF is parallel to the bases and that EF is the average of the 2 bases, okay? So first, what is the slope of AD? It is 0. It's 0 minus 0 over D minus 0, which is 0 over D, which is 0. What is the slope of BC?
0.
It's B minus B over C minus A. So it's 0 over C minus A. So it's 0. So the first thing I need to do is prove that EF has a slope of 0. I have to find the midpoints. So what is point F? Well, that's going to be the average of D and C. So D plus C divided by 2, comma, 0 plus B divided by 2. And point E, similarly, is going to be A over 2 and B over 2. Okay? Keep in mind, this is D plus C over 2, comma, B over 2. All right, so if I want to find the slope of EF, it's, let's see, B over 2 minus B over 2 over A over 2 minus D plus C over 2. Now, what's all that matters about this crazy complicated fraction for our proof? All that matters is the top is, what's B over 2 minus B over 2? The top is 0. So we have just shown that EF is parallel to BC and AD. And you see how we prove that without any numbers? So that means that's true for every trapezoid. Now this one's going to be super hard, but this is why we're in accelerated geometry and you guys can do it. It just takes a ton of algebra. You're going to have to be neat. Okay? Also, understand that it's hard to ask a lot of these on the test, so you just have to have a concept for this. It won't be probably this rigorous on all of the test questions. All right, so we need to find, so again, E, I shouldn't have erased it. E is, let's see, A over 2, comma, B over 2, and F was C plus D over 2, comma, B over 2. And how are we going to find that it's the average? We have to find the distance between E and F. So the distance, I'm just going to take my time and plug it in. It's B over 2 minus B over 2, sweet, squared, plus, this is going to be harder, C plus D over 2 minus A over 2 squared. Okay, here we go. Just see what we get for it. So the distance for that then, this is 0 squared, which is just 0. This we can combine into a single fraction, so it's C plus D minus A all over 2 squared. So it's the square root of C plus D minus A times C plus D minus A all over 4. Okay, that's not bad, because when we do this squared, it's just going to be C plus D minus A over 2. That is the distance. Okay? Now, how big is the lower base? It's D. Just like wrap your head around it a little bit. How big is the upper base? Get it, Hallie. What do you think? Not A times C. So let's say if this was like 2 comma 2 and this was 10 comma 2, then how big would AC be? Wouldn't it be 8? 10 minus 2? So our top length is just C minus A. And what are we trying to prove? We're trying to prove that this distance, which we just found, is the same as the average of the bases. So let's find the average of the base. It would be D plus C minus A divided by 2. Doink. Got it. So these can be kind of satisfying, but they're certainly challenging, and I'm here to help. That's the end of the video. Boom!